Rags is going to be signing some free autographs, some free posters after her flight, so you can be sure to see her and say hi. And Chuck, where will you guys, you know where you're going to be?
Down by the South Jumbotron to start.
Okay, South Jumbotron to start. Chuck, very, very good to have you here, buddy, and a great performance by Jill Long. Thanks, Chuck. And you can show your support of Living on the Ragged Edge by purchasing Ragged Edge wear. T-shirts and hats are available, and Rags will gladly sign them for you as well. Coming up in just a minute, the United States Marine Corps' AV-8B Harrier, as we thank more of the great sponsors of today's show, including Mid-Atlantic Waterproofing. They specialize in controls. Is Captain Ryan Patty Howe. And with me is Captain Jack Ash from Cherry Point, from VMA 231, the Black Aces. And he's getting ready to do something that almost no other airplane in the world can do. Right, Jack?
Oh, absolutely. One of the great things about the Harrier is it has movable thrust nozzles. And what that's going to allow him to do right here is take off in very short distance. He's already off the ground. Using those variable thrust nozzles, get himself off the ground.
And 1960s, when the Hawker Aircraft Company in Great Britain was working on a vertical short takeoff and landing aircraft concept that used something called vector thrust. The thrust of the jet engine usually comes straight out the tailpipe, but in this case, the AV-8B Harrier and its predecessor back from the late 1950s and 60s, known as the B1127 Kestrel, was the first to vector the thrust or change the direction the exhaust gases were coming out of the jet engine to 90 degrees and actually to about 100 degrees. So that plus two nozzles in front of the wing would bleed air from the engine enables this airplane to take off and land vertically. From the left, ladies and gentlemen, from the Black Aces, here comes your United States Marine Corps' AV-8B Harrier II. Originally, this aircraft, the original Kestrel, was powered by a Rolls-Royce Pegasus engine that generated 10,000 pounds of thrust. But Jack, that thrust in technology has changed, and the AV-8B Harrier II has a lot more.
Absolutely. Now the Rolls-Royce engine inside the Harrier II Plus is running about 23,400 pounds of thrust, which runs approximately 35,000 horsepower, which gives us a lot of extra advantage when we're out there supporting those Marines on the ground.
Now, as it moves in from the right, as Patty comes in here, what are we going to see coming up?
All right, what you're going to see coming up now is he's going to be coming in from the right at low altitude, high airspeed, and he's going to be doing the brake maneuver into the landing pattern. He'll come in here nice and low. He'll probably lose me for a sec as he gets a little loud, but he's going to brake off to the right, 90 degrees. Get into a landing configuration. This allows him to slow himself down from that high speed taxi we just did in order to get into the vertical environment to do the landing you're going to see here shortly.
Now, as he comes around, I noticed something under the wings as he turned away from us. There were a bunch of pieces coming down. Oh, before I get this, to support the Marines on the ground.
Absolutely, and one of the great advantages we have with the short takeoff and landing capabilities is that we can support the Marines on the ground from unapproved locations and expeditionary operations. Now what you're going to see here coming in from the right, he's coming into a decel, which means he's slowing himself down into a hover. It's going to get a little loud, I'm going to lose you for a minute, but what you're going to see is, as he comes into the hover, he's going to maneuver the aircraft around using some exhaust air bleed out reaction control system I'll tell you about in just a minute. And here comes a demonstration from the AV-8B.
It's Harrier Ballet. round of applause for your United States Marine Corps AV-8B Harrier II. I'll tell you what, Jack, that's pretty impressive. Now, you talked about a reaction control system, and that gets, how does that work?
Well, the reaction control system, what it does is, when you get to the hover, you're not in conventional flight anymore. You're using what we call our V-stall flight. And that is going to duct some of the air out of the engine. Most of it's going straight down to keep you hovering in the air. But it's going to move some of it out depending on what the pilot does in the cockpit and push it out either the left or right wing or under the nose or under the tail to help him manipulate. As you saw, he came in, was able to back up the aircraft, move left and right, and then even spin it around in a circle. So being able to do that is by using that reaction control and letting the air come out in different locations.
This is really not unlike how the space shuttle changes its position while it's in space. It's the same sort of thing. They actually use the air as a mini thruster or a mini jet to change positions.
Absolutely, it's very similar to that, and what it allows us to do is, again, use the vertical operations for the short takeoffs and have good manipulation of the nose as we're doing this environment where we're not having that much airflow over the wing.
All right, well, Putty is now doing what, Jack?
Right now what he's doing, he's letting the engine cool slightly after he just did that hover work.
All right, 23,000 pounds of thrust. He's spooling it up. Look at those big intakes. Get a lot of air in. This airplane doesn't fly faster than the speed of sound. It doesn't need to, but you see the flaps come down. The nozzles will shortly come down, and he uses an actuator where? How does he make that change the position of the nozzles?
The nozzles are moved right next to the throttle on his left-hand side. He's able to move them down. He's about to put the power up and start getting himself to a climb away. As you'll notice a little bit of exhaust coming out. What you think is that? I'll tell you, that's burning water.
For the location of a jet. I see a whole lot of smoke coming out of that. What's going on with that?
Well, one of the things that the actual thing that this aircraft is made for is air-to-ground support. We're always out there trying to support the Marines on the ground. And in order to do that, we have a large number of ordnance that we can carry, almost anything conventionally in the U.S. arsenal. Primarily, we work with laser-guided munition, precision-guided munition, all kinds of ordnance, as well as a 25mm gun on the aircraft.
Now that 25mm gun, that's 25 millimeters. That's a little over about an inch in diameter shell. That's pretty potent stuff, isn't it?
Absolutely, very effective when it is used in that way. Now he's coming in right now for what's going to be called an RVL, a rolling vertical landing. It's slightly different than what you've just seen. Basically, he's using those nozzles to slow himself down to approximately 60 to 50 knots. And by slowing himself down that way, he doesn't need very much runway in order to roll out. He'll probably roll out a little longer just to give you a little bit of a show. But truly, he doesn't need any more than approximately 500 feet to stop the aircraft from coming out of this landing.
50 knots or 60 knots is just about 70 miles per hour. A nautical mile per hour is fast. They call it a knot. It's actually 15% faster than a statute miles per hour like we see on our speedometers. And there he is rolling it out. That is Captain Ryan Putty Howe from the Ace of Spades VMA 231 at Marine Corps Air Station Cherry Point. That's pretty cool, Jack. Now, how long have you been flying the Harrier?
I've been here for about 3 years. He has about 6 years under his belt behind the Harrier. And real quick, before we get out of here, I have a son up here. Sam Howe is turning 5 today, so we just want to say happy birthday to Sam.
Let's sing happy birthday to Sam right now. your attention over to the left and high at about 2,000 feet above the ground.